Hello mathematicians, we're going to have a look at translations of the parabola. Now this is not entirely new work for you because we looked at translations when we looked at functions early on. But what this will allow us to do is to look at the cases when the vertex of the parabola is not at the origin. And our normal rules for shifting the curves around the plane apply. So if we want to move the vertex from 0, 0 to hk, what we're going to do is to replace the x by x minus h, so we've seen that in action before, and the y by y minus k. And then that gives us the ability to read off the vertex from our equation. So every parabola whose axis is vertical or horizontal has an equation that can be put into exactly one of the four forms, and then with those four forms we can move the vertex from the origin to the point hk. So let's have a look at this in action on GeoGebra. So if we look at our parabola here, we can see that at the moment it has its vertex at the origin, and that means that h is 0 and k is 0, and for what it's worth, this parabola has a focal length of 1/4. So therefore its focus would be at 0, 1/4, and the directrix would be at y equals minus 1/4. But we're interested in what happens if we change the value of h and k. So if I select the h here, if I shift h to have a value of 1, then my parabola, if you can look at the equation up here, x squared minus 2x minus y equals minus 1. Now this is going to require a little bit of thinking on your part, but if I rearrange this to be x squared minus 2x plus 1 equals y, then that gives me x minus 1 all squared equals y. So that indicates that I've shifted the x-coordinate a distance of 1 unit to the right. So we'll practice that technique much more later on. Unfortunately, GeoGebra can't easily cope with writing the equation in that fashion. So I can switch, change the value of h to shift to the right or to the left. And I can also, if I go back to the origin here, if I change the value of k, then if k is 1, the parabola is shifted up. If we look at this equation here, then I need you to think of it as x squared equals, and I'll shift the y over to the other side, so I've got y minus 1. So if x squared equals y minus 1, that's telling me that I've shifted the axis up by 1, because the value of y that makes the bracket on the right hand side 0 is y equals 1. And likewise, I can shift it down, I can shift it across as well. So we're going to be spending quite a bit of time rearranging the equation written in, I guess, some version of Cartesian form, and putting it into the form where we can read off the vertex straight away. So what we have here are the four forms that we can put it into when we move the vertex. So if we've got this form here, so notice that this is just our x squared equals plus or minus 4ay if we've got the focus at, if we've got the vertex at the origin, so when h and k are 0. So if we put h equals 1, for example, and k equals 1, then we've shifted the vertex to the right by 1 position and up by 1 position. This arrangement here is the set of parabolas which are lying on their side. So again, if k and h are both 0, this is the case where y squared equals plus or minus 4ax. And changing the value of k and h does the same thing. It moves it to the right in this case and up in this case. So A is the focal length, as we know. HK we can read off as the vertex directly. So if we look at this example here, then what we're trying to do in the first one is write down the equations of the two parabolas that have a focal length of 3, a focus of 2, 1, and an axis parallel to the x-axis. So if we pick up clues there, first of all, the fact that we have the axis parallel to the x-axis means that it's going to belong to the family which is of the form x squared equals 4ay. But because the vertex is not at the origin, it's going to then be of the form x minus h squared equals plus or minus 4a outside of y minus k. So let's think about what this means in terms of our sketch of the parabola. So we're told that we have the focus at 2, 1 and a focal length of 3. So if we come out and mark the focus at 2, 1, so here's our focus. Now that focus could be inside the parabola, either concave up or concave down. So if the parabola was concave up, then it means that the vertex would be 3 units down this way. So we would go to the point 2 minus 2 as the vertex. So our parabola would look like this. And in that case, what would its formula be? Well, as we saw before, it will now be x minus h, so that's x minus 2 all squared, equals 4a. Now in this case, the focal length is 3, so 4a is 12. It's concave up, so it has a plus sign in front, which we don't write, and it's y minus 2, which is y plus 2. So that's the parabola. Well, that's one of the parabolas that we could have. Now I'll just change the pen colour. If we look at our other possibility, if again 2, 1 is the focus and we have a focal length of 3, then from the focus to the vertex could be this way, which would take us to the point 2, 4, and to have the focus inside our parabola, it must be concave down. And that particular equation for the parabola would be x minus 2 squared equals minus 12 outside of y minus 4. So these are our two parabolas. We've just sketched them. I think it's hard to do it without sketching, or I would find it hard to do it without sketching. And then we need to find and describe their points of intersection. So we know that that means solve them simultaneously. So if we look at these equations here and set about solving them simultaneously, we can see that this x minus 2 squared equals this, and it equals this. So therefore 12 times y plus 2 must equal minus 12 times y minus 4. So 12y plus 24 is minus 12y plus 48. 24y equals 24, so that gives us that the y value is 1, and picking either of them, x minus 2 squared equals, and if I put y equals 1 into equation 1, then I'll have 12 times 3, which is 36, so x minus 2 equals plus or minus 6, so x equals either 2 plus 6, which is 8, or x equals 2 plus minus 6, which is minus 4. So these are our 2 points here, minus 4, 1, and 8, 1. And even on my ordinary sketch, that looks realistic. Let's look at our next example. We need to find the focus, directrix, focal length, and endpoints of the latus rectum of this parabola. Now what we know is that this parabola is concave down because of the minus x squared. We also know that we could sketch this at the moment. We could possibly find the roots of this equation. We could find the coordinates of the vertex by finding the axis of symmetry and the y value, but for us to be able to find the focus and directrix, we need this. We need the focal length, which means that we're going to have to arrange our parabola in one of the 4 standard forms. Now, which one of them is it? Well, because we've got an x squared, we know that it's the standard form x minus h all squared equals 4a outside of y minus k. And for what it's worth, because this parabola is concave down, we know that there must be a negative out there. So now we set about changing, rearranging, transforming, is probably the more mathematical word, this equation into this layout. So let's take all of our x, what's on the right hand side basically, to the left. That'll become x squared plus 4x plus 3, and that will equal minus y. And if I then remember that I want a perfect square here, what would I have to do? I would need half of this squared on the end, so I'd want x squared plus 4x plus 4, which means that I've added 1 to this side, and therefore I've got to add 1 to the other side. So that will give me, lost that squared, that will give me x plus 2 as my perfect square. Over here I want a negative out the front, so if I take a negative out the front, that gives me this. So then, reading off this, I can see that HK, so the vertex, is at negative 2 plus 1. Focal length occurs when, that's a 1 there, so when 4a equals 1, so therefore a equals a quarter. And we know that the negative is telling us that it's concave down. So, the focus, directrix, and focal length. So, if we mark the vertex, so negative 2, 1, so it's here somewhere, and it's concave down, so it's going like this, and we want the focal length to be a quarter, and it will go down this way, then the coordinates of the focus itself will have our same x value of negative 2, but it will be a quarter lower than the vertex, so it will be at 3/4. The directrix is going to be the line above the vertex, and it will be the line y equals 1 1/4, or 5 on 4. So we've got this, this, this. The endpoints of the latus rectum of the parabola, well, the latus rectum, we know, is the horizontal line, the focal chord that runs through the focus and is parallel to the x-axis. So the equation of the latus rectum is going to be y equals, and it will be y equals 3/4. So to get the endpoints, this point here and this point here, we want to have where 3/4 gives us 2 x values. So we go back to our equation here, so that will be where x plus 2 all squared equals minus 1 outside of 3/4 minus 1, which is minus a quarter. So x plus 2 all squared equals 1/4. Therefore, x plus 2 equals plus or minus a half. So x equals minus 2 plus a half, which is minus 3 on 2, or x equals minus 2 minus a half, which is minus 5 on 2. So the endpoints of the latus rectum are going to be minus 3 on 2 and 3/4, and minus 5 on 2 and 3/4. What is it that you need to include in your summary now? And then go on and practice the exercise.